Let's graph this system of linear inequalities. The first line we have to graph, the first area that we have to graph, is y is greater than or equal to x. There are two things you need to know about every line when you graph a linear inequality. The first thing is the boundary, and the second thing is which side of the boundary do you want to be on when it comes time to shade things in and indicate where the solutions are. Well, the first thing to know about line number one is it's already in slope-intercept form. The boundary is going to be the line y equals x, which is the perfect diagonal through the origin. Well, I don't know if I'd call that perfect, but it's close enough for our purposes. The boundary can be of two types. It can either be a dashed boundary or a solid boundary. Solid boundaries indicate that the points on the line are also part of the solution. And you should use a solid boundary whenever you have an operator for your relation that is greater than or equal to, or less than or equal to, or obviously equal. In this case, our operator is greater than or equal to. That means that our line should be a solid line. The final question to answer, of course, is which side of this line should we be on? Well, if any point on one side works, every point on that side will work. So let's pick a point that's on a particular side. Let's choose 0, 1. Well, if I put 0, 1 in, then 0 goes in for x, and 1 goes in for y. Is 1 greater than or equal to 0? Yes, it is. So this point works. And every other point on that side will also work. Now, I don't know that I want to make a big old mess out of things right now, but it's important to know that this is the side that works for green. So that's line 1. For line 2, we have a little more complicated situation to deal with. Our boundary is going to be the line x plus 3y is equal to 5. Notice that our operator does not have the or equal to symbol attached to it. So this time our line is going to have to be a dashed line when we put it in. Well, to graph a line, we need 2 points. Using our knowledge of lines in standard form, we know the x-intercept is going to be 5 over 1, and that the y-intercept is going to be 5/3. Remember that if we label these values for 1, 3, and 5 as A, B, and C, then the x-intercept is going to be C over A, and the y-intercept is going to be C over B. So that's how I got those values. For x, then, we have 5 over 1. The x-intercept is 5, 0. So this point is on my boundary. The y-intercept is 5/3. That's the same as 1 2/3, and that is also on the boundary. So now we need a dashed line that goes through those 2 points. So there it is. Finally, for our third line, the boundary is going to be 2x plus y is equal to -3. Note that our operator this time has the or equal to sign attached to it. So we will have a solid line this time. Let's stop for a moment and go back. I forgot to show you. For line number 2, we also need to decide which side of that purple dashed line we should be on. Conveniently, this line, unlike the green line, does not go through the origin, so we can use the origin. Put 0 in, and 0 in. 0 plus 3 times 0 is 0. Is 0 less than 5? Yes, it is. So the origin does work. Again, I don't want to clutter this graph up, but I do want to give a clear indication of where the purple region is, and it's on this side. Okay, now on to the third line. 2x plus y is equal to -3 is our boundary. We determined that we need a solid line. We need 2 points. As before, we can use the properties of lines in standard form to find our points. For C over A, we have -3 over 2. So our x-intercept is -3/2. That would be right here. Why I'm working in purple, I'm playing with the red line. There we go. For our y-intercept, C over B, which is -3 over 1. So our y-intercept is -3. Again, this will be a solid line, so let's draw that now. So there's a pretty good approximation of that line. Again, we need to determine which side of that line we want to be on. And conveniently, once again, the origin is not one of the points on our line. So put 0 in for x and 0 in for y. 2 times 0 is 0, plus 0 is 0. Is 0 greater than or equal to -3? And no, it's not. So we want to work on the side opposite the origin, over here. Looking carefully at our x's, we know that we want to be above the green line, below the purple line, and to the left of the red line. To accomplish all three of those goals, we should be in this range right here. This is the region on the plane where we are true for all three conditions. These points satisfy all three inequalities. So this is the solution of the system of linear inequalities.